Bolts often come loose due to dynamic vibrations. The bolt always tries to loosen due to the angle of the thread. In static conditions, loosening is prevented due to friction on the thread and from bolt or nut surfaces. Any movement between the parts in a joint jeopardizes the security. We will now see what happens to the bolt tension in a joint when the material under the nut vibrates laterally. At first, we tighten to a bolt force of 20 kN. The nut starts to loosen and the tension drop. Old methods for securing bolts use locking wire, tab washers and castle nuts. The assembly becomes time-consuming and the security varies with the skill of the mechanic. Dismantling is always tiresome. Bolt securing is now often done with adhesives. With these methods, there is a curing time before the bolt is locked. Moreover, the surfaces must be dry and clean. Dismantling, again, is always tiresome. Other methods try increasing friction in the thread and towards the material. This can be achieved by nylon insert in the thread, deformation of the thread, serrated washer, serrated bolt head and nut, or spring washer, often with limited success in vibration environments. The security varies since the friction is not constant. You will see from these vibration tests how the bolt force drops when the nut unscrews itself. We are now carrying out the test with a nylon insert nut. Now a deformed nut. Here we run a spring washer. Locking nuts with friction added onto the thread do not fall off, even if they partially loosen. There is no guarantee of a high tension being maintained. Another method is double nuts. These also spin loose. Sharp serrations and enlarged heads and flange nuts cause more resistance when tightening. This influences the bolt force. When a standard nut of size M8 is tightened with a torque of 25 Nm, we achieve a force of 28 kN. A nut locked with a serrated washer gives a force of 20 kN from the same torque. With a serrated and flange nut, the force stops at 12 kN. The preload output is lower due to high friction. Lubricated surfaces give an even bolt tension to bolts tightened with a constant torque. The safety decreases if the surfaces are well lubricated due to the bolt turning more easily. The higher force doesn't bring the extra safety. Larger bolt sizes must be lubricated if a proper preload is to be achieved. Here we can see the difference in bolt force using dry and lubricated surfaces. The Nord-Lock washers have cams on one side and radial teeth on the other, and are installed in pairs, cam face to cam face. When the bolt and or nut is tightened, the teeth grip the mating surface. The washers lie still during tightening when the sliding is towards the upper washer. Since the teeth cause some extra tightening resistance, the torque should be 20% higher and is recommended for a flat electro-zinc plated surface. When unfastening, the teeth grip and the washers slide on the cams where the friction is low. There is no scratching of the material surface. The cam angle is greater than the pitch of the bolt. Consequently, the cam action generates a small increase of the force before the bolt is completely unfastened. This increase of the force can only arise when unfastening. The tension does not reach the yield point when unfastening. There is no risk of stretching the bolt. A bolt locked with Nord lock can never start turning from dynamic loads, and consequently it can never vibrate loose. The cam action makes the tension lock the bolt and not the friction. The Nord lock bolt securing system gives 100% safety at any friction condition. Here we have locked the nut with Nord lock and tightened with 30 Newton-meter. The initial bolt force, 20 kN, is reduced by 10% due to settlement, mainly in the thread. The nut can't vibrate loose since the bolt force must be increased. Now, when we unfasten the nut, you notice how the force increases slightly. The unfastening torque is only 20 Newton-meter, considerably lower than the tightening torque, since the sliding goes between the smooth cam faces. We now lubricate the nut to reuse the fastener. Notice that the joint is as safely locked as the first time. The washers can stand the same temperatures as the bolts. Reusing is no problem since Nord lock has a hardness of 48 Rockwell C. This is higher than the hardness of high-grade bolts. The surface of the materials is of no importance. It can be rough or ground, but it must not be harder than 45 Rockwell C. Tightening towards a painted surface gives 100% safety. Remember, the friction is always lower between the washers than the teeth sides during loosening. When reusing, it is always important to lubricate the bolt to achieve a high bolt force. This is more important for larger bolt sizes. Lubricated fasteners always make tightening and unfastening easier. Nord lock, the simple and safe method to secure bolts.